So now that we know how to dump and crack hashes for Windows systems, I'm going to be showing you how to do the same thing for Linux systems. But before we start, I will have a look at a couple of important concepts that are going to be relevant for this lesson. So in Linux, you have a couple of files, so the etc password and the etc shadow files. And in the etc password, you store information related to the users that are defined in the system and some information associated to those users. And then in the etc shadow file, you store information related to the authentication process. So this is how the etc shadow file looks like. So first you will have the username, then a semicolon that is used to separate the different fields, then the ID of the algorithm that is using to do the hashing process. In this case, if you see a $1, that would be MD5. Then a salt, so that's some random data that the operating system is appending to every user password to make it unique, okay? And then you have the hash of the password. So in here it says encrypted password. Encryption and hashing are not the same thing, so it would be more like hashing of the password, okay? So after that, you have some other fields that are not really relevant for this lesson, like, for example, the last password change or the minimum days allowed until you need to change the password again and so on, okay? So now let's go to our Kali VM. And I wanted to tell you that I was having a look at the shadow file that was created in my Kali Linux, and I realized that it is using a format that is not that common for the hashing. So if we do a cut of the etc shadow file, by the way, you need to be root, or you need to have elevated privileges to do a cut over this file because it's protected. You will have a look here that, for example, in this out-of-the-box user Kali, the hashing algorithm is not $1 or $5 or $6, which are the most common you will find in any Kali, in any Linux distribution. They are using the $Y. So I was having a look at the official documentation. It was a bit hard to get which hashing algorithm is this one, but they are using JScript. And the reason why they are using JScript instead of MD5 or SHA-1, SHA-256 is because JScript is really cracking resistant. So it takes a lot of time to do the cracking process over this shadow file. Okay, so if we try to do it, for example, if we copy the etc shadow file here, so we have the shadow there, and we do John. Let's use this word list, for example. User share word list raq, and then we use this, the shadow. So out of the box is not going to be even detecting the format. As I was saying, it's a weird format. So we need to specifically say to John format equal crypt. And then it's going to be able to load the hashes and start doing the cracking process. But as you will see, if I click enter, it's not even progressing. So it is super slow. It will take ages to really do all the cracking process. So for that reason, let me clear this. I was taking a different file, this one, the shadow MD5 one. That's the one that we are going to be using for this lesson, okay? So as you can see here, we have the $1 indicating that the hashing algorithm is MD5. So let's try to execute the same command, in this case, against the shadow MD5. This is going to be taking a while, so let me first try another dictionary, the 500 words, that is going to be able to crack some of the passwords. Okay, so this one, with this dictionary, we were able to retrieve the password, in this case Batman, for one of the users. And then let's use the Rocky one to try to crack the rest, okay? Okay, so it already got a couple of passwords for these users here. And this one is going to be faster, but is going to also take some time. So I'm not going to be finishing the cracking process because it will take time, but I just wanted to show you the main concepts around the etc password, the etc shadow, and how can you use John the Ripper to crack Linux passwords. So that's it for this lesson, and see you in the next one. Bye.